Today I will explain a bit what RPSL is, what is RPSLTool, which is a program I wrote, and how RPSL and RPSLTool are useful for internet providers. RPSLTool is a program which has a single well-defined basic purpose, which is to generate the configuration for BGP sessions. They can be the sessions to your customers, to your peers at an exchange or private peers, or it can be used to generate the big configurations of root servers of internet exchanges. You can use it with statically defined lists of routes and autonomous systems, but it is really great if you can use IRR data, that is, in Europe, the objects registered in the RPSLTools database. RPSL is the language used in the RPSLTools database. The whole RPSL language can specify an entire configuration for an autonomous system. On the other hand, RPSL is an old protocol. It is very, very complex. It was invented at the time when it was thought to be a good idea to try to define your network, trying to describe your network configuration in an abstract way. You can see here a list of the objects which you can use. There are the most common ones, like person, role, used for contacts, Outnum, which is an object which describes an autonomous system, and a root object which describes routes. Then there are also a lot of less common objects. Have you ever seen an RTR set object? So I think 2, maybe 3 networks in the whole world use RPSL to define their complete configuration. If you are curious, you can download from the RPSLTools site the database dumps and have a look at the objects. And you will see that most of the complex objects are abandoned 10 years ago. Nobody uses these things. Even the most common objects, like root, have a lot of unusual attributes which can be used if you want to describe a complex configuration, but again, nobody ever does this. RPSL is a complex language. Unknown objects are the core of the specification, and starting from there, you can describe your whole routing policy. Many networks do it in a very simple way, listing their peers, their customers, their transits, but not actually describing what is their real the real configuration in their hardware. This is a short example which tries to describe a real-world configuration. It was actually used about 10 years ago, but it can get even more complex. And anyway, the problem is that trying to describe a real-world configuration in such an abstract way rarely works. The Unknown object can be useful either in this way or to document to third parties what are your peers, transits, and customers. You will ask yourself, why should I do this? And indeed, there is no good answer. There is no real point in trying to use RPSL this way. The root objects are used to match an IPv4 or IPv6 route to the autonomous system announcing it. This is more useful because the RIPE database has a complex authentication scheme which only allows authorized entities to create root objects. So when you see a root object, you can be quite sure that the information it contains is trusted. So you can use this to generate accurate prefix filters for your peering sessions, or to validate what routes your customers should be allowed to announce. I want to spend just a minute on a very recent addition to RPSL, which is the pingable attribute of root objects. You can use it to describe an IP address, IPv4 or IPv6, which can be used by third parties for debugging your network, for trace route pings and so on. This is a real-world example of one of my root objects. I published this IP address, which is anycasted over my network and can be used by other operators to check reachability of my network. This AES set object is a simple list of autonomous systems. It can be used to define a list of customers, a list of peers, and it is one of the building blocks of routing filters. This one is the real world object which lists my own autonomous system and my downstream customers. This means that if you look up each route announced by these autonomous systems, you will be able to build a complete and correct prefix filter for peering sessions to me. Once upon a time, this kind of configurations were generated by IRR toolset. It is a very old tool born at Merit in the United States in the Routing Arbiter project, which is where RPSL came from. It is a very complex software, and at the time when I tried to use it, it was unmaintained. It did not build on modern systems. With a lot of backing, you could make it compile, but then it just crashed or generated incomplete filters, which is quite bad, because then you will start rejecting good routes from your peers. Since a couple of years, maintenance is hosted by ISC. There is a new maintainer who is very active, and it has been fixed and it can be used again. But still, it is a very complex program, because it tries to implement and actually implements all the features of the whole RPSL language. I wrote RPSL tool because I do not like repeating boring tasks like generating filters for peering sessions and configuring peering sessions. Now with 4-5 lines of configurations, I can generate the complete BGP configuration from scratch for either a customer or appear at an internet exchange. And not only the configuration, but also the filters. So I do not need, my customers do not need to warn me when they will start announcing a new prefix. They can just register it in the right database, and the next day the filter will be automatically updated. IRR toolset used to be over 70,000 lines of C++. After a lot of the less useful parts were removed, nowadays it is down to 26,000, which is still quite a lot. The parsing autonom objects is complex and requires a lot of work. This is why I totally ignore them in RPSLTools. RPSLTools is a very simple program, less than 2,000 lines of code. Part is Perl, part is Template Toolkit, which is a simple declarative language which is often used to build websites, but it is a totally general purpose templating system which can be used to generate anything. IRR toolset can use the complete RPSL configuration to generate the whole routing policy of your network. But actually, why should you advertise publicly to everybody your internal routing policies? RPSL was born in an academic context and in times when this was not considered a big issue. So RPSL is a much smaller tool, much more focused, which has a simpler task, generating the BGP configuration and the associated prefix filters, or ASX filters. You do not need to filter by prefix if you do not want to. IRR toolset uses the whole RPSL, while RPSL toolset uses only root 6 objects, which define which autonomous system is authorized to announce a specific prefix, and ASX and RSX, which are lists of autonomous systems and routes. RPSTools does not use the autonom objects as the start to generate the configuration, but uses a simpler configuration language. It is built with Perl, Template Toolkit, one of the with client Perl modules, and the YAML, which is a very simple serialization format, which is actually very, very close to JSON, and it is commonly used in the Perl ecosystem to write configuration files. The beauty of this system is that by changing a template, you can change the output with the same configuration. Some internet exchanges use RPSL tool to generate from a single configuration both the configuration for different BGP implementations. I provide templates for iOS and Junos for an ISP configuration, and for Bird and OpenBGPD for route server configurations. But writing new templates is very easy, and you can adapt these ones to your needs. RPSL tool used by Mix, the internet exchange in Milano, Minap, which is the alternative internet exchange in Milano, and I am discussing with Namex what new feature they need to use it in Rome. Namex is the exchange in Rome. I use it to configure all my customer and peering sessions, and I know other ISPs, both in Italy and abroad, who use it the same. RPSL works using as an input a list of your peers with a few simple attributes which describe things like their IP address, which routes you want to import, other parameters, and configuration file templates which will describe the output, which is usually the complete BGP configuration for the peers or customers described in the input. And then it can use IRR data from RIPE with server or compatible with servers to generate to generate up-to-date prefix or autonomous system filters for your neighbors. By using the conversion feature of the RIPE with server, you can also import routes from other IRR databases, because RIPE mirrors in their own database other sources and converts them to RPSL. This is an example of the main configuration file. For each one of your neighbors, you have to list the most basic parameters, their autonomous system, a description if you want, which will be copied to the output, and which routes you want to import. Here you can see two simple cases. First one is an AES set of the Italian Research Network. Starting from the AES set, you recurse, you get a list of autonomous systems, and for each one, RPSLTool will be able to find out the list of routes which each autonomous system is authorized to announce. In the second case, we have the FRoot instance in Rome, which does not have a root object, a root 6 object in this case, registered in the right database, so I just specified the single route they announce. Then there is the IP address of the neighbor. You can see in the second example that there is also a backup IP address, which is the second peering session, because Namex has two LANs like links. Other things are the AES list number for iOS, which does not allow to specify named AES autonomous system lists, or in the second case, arrow BGP command to be copied in the configuration, the session password. This one is just a tiny fragment from the iOS configuration. Template Toolkit is a very simple templated language. It has if conditionals for loops and so on. Data is presented as pseudo objects. You can see in the first line that there is this structure name, which contains the list of all neighbors, which has members for IPv4, IPv4 multicast, IPv6, and so on. Then there is an import routes method, which extracts the list of routes from RPSL, and size is a template toolkit keyword which returns the size of the list. So in this line I just check if there are or not routes for this address family. And if there are routes, you see in the third line that the template iterates over the list of routes and generates the prefix list. In the end, you see this pseudo method route to Cisco, which converts the plain CIDR prefix in the format used by Cisco prefix list. So with the template, you can define every detail of your configuration. I provide a sample template, but it is not supposed to be good for everybody. You will have to adjust it a bit depending on your needs, the general structure of your configurations and so on. You can also use RPSLTools in a different way. This is a complete example of a different kind of template. This one does not use a configuration file with a list of neighbors. It's just a template by itself. I define in the first line a variable, which is in this case an AES set, and then it is expanded, sorted by the AES number, and printed, and the routes for each autonomous system are printed after aggregation and sorting as well. So you can use to generate lists of prefix, various things. I used this one to generate configuration for IRC servers. As an operator, what you should do about the RIPE database? What I recommend is that you always define root and root 6 objects for your routes and tell your customers to do the same. This does not take a lot of time. After that, does not need any further maintenance, and really helps your neighbors who want to filter peering sessions with you by prefix, because this is all you need to let third parties to generate filters. This may also be useful for you because some transit providers actually used the IRR to generate filters, your customer filters for you. They do not always advertise this. You need to ask. I recently discovered that TNet in the last year started supporting this. So now, every time I get a new customer, a new prefix, I do not really need to write to them as well to update my filter. Do you need to maintain an Opnum object? Not at all. There is really no point unless you are using it to generate your configuration, and this is something that I believe only the Greek research network still tries to do, but I have not checked in the last few years. But anyway, you need to have one because RIPE creates it when you get a new autonomous system. It's a good idea to keep it up to date, because other people may want to have a look at it and for debugging purposes. So try to at least not put informations which are going to get out of date in it. RPSL in the RIPE implementation supports some very complex rules. It's a couple of flowcharts of 15 passages and so on, which specify who is allowed to create or delete a route object. This way, only the entity who has been assigned a network or an autonomous system is authorized to create an object. And this means that third parties will be able to tell with certainty if a network has been announced, if you are allowed to announce a certain network. And Opnum objects can also be useful for documentation purposes for your transits. As an example, Cogent supports their NOC can look at the Opnum objects of your customer and they will use this to decide if you are allowed to announce their routes or not. But this only works in the RIPE region because most other IRS do not support the authorization rules, and everybody is allowed to create new objects. Why filter peering sessions? I suggest that if you do it, if it is possible at all, and if it is practical for you. In Italy, I'm able to do it to do this for almost all of my neighbors. I think all national neighbors can be filtered, if not by prefix, at least by a list of allowed autonomous systems. And these apps, from time to time, when somebody gets a filter wrong and they start announcing a full view, at least the session to them does not break. But this depends on how much your neighbors keep their root objects up to date. I don't know how it works here. Are there any questions? Thank you.